Try it right now. Run your own finger along the bottom of your foot. Nothing happens. No squirm, no laugh, no shiver up your spine. Now imagine someone else doing the exact same motion, with the exact same finger, at the exact same speed. You would be on the floor. Same touch. Same nerve endings, same skin. So why does one version feel like nothing and the other feels unbearable? The real answer is far stranger than ticklishness itself. Your brain is not reacting to your skin. It is reacting to a prediction. And the moment it can predict something perfectly, it stops caring about it entirely. This sounds backwards. You would think your brain pays the most attention to the things it understands best. But for touch, the opposite is true. Predictability is dangerous. Predictability means a threat could move in plain sight, hidden inside the noise of your own body. So your brain built a filter, a silencer, a system whose entire job is to mute anything you do to yourself, so the only signals left ringing are the ones that come from outside. This filter has a name. Scientists call it sensory cancellation, and it begins in a part of your brain you rarely think about: the cerebellum. Most people know the cerebellum as the balance center, the thing that keeps you from falling over. But it does something else, something far more strange. It runs a constant simulation of your own body, just slightly ahead of real time. Before your finger even reaches your skin, the cerebellum has already calculated exactly what that touch will feel like, exactly how much pressure, exactly which path it will travel, exactly when it will arrive. This calculation is called a forward model. Think of it as a weather forecast for your own movements. Your brain isn't waiting to feel the touch. It's predicting the touch before it happens, then comparing the real sensation against the forecast. If the forecast matches reality almost perfectly, the brain decides there's nothing new to report. It dampens the signal. Sometimes it cancels it almost completely. This is why you cannot tickle yourself. Your brain already knew the tickle was coming. It told your nervous system, in advance, exactly what to expect. By the time your finger actually touched your skin, the surprise was already gone. And ticklishness, at its core, is built entirely out of surprise. In the 1990s, a neuroscientist named Sarah Jane Blakemore set out to test this idea directly. Working alongside Daniel Wolpert and Chris Frith, she built a simple but clever machine. A person would move a foam paddle with one hand, controlling a second paddle that brushed against their other palm. Sometimes the second paddle moved in perfect sync with the first. Sometimes there was a short delay, half a second, sometimes more. The longer the delay, the less the brain could predict it. And the less the brain could predict it, the more ticklish and intense the sensation became. Pause on that for a second. Just by adding a small delay between your own action and the resulting touch, researchers could partially restore your ability to tickle yourself. The forward model relies on timing. Break the timing, and the cancellation breaks with it. Blakemore's team went further. Using brain imaging, they watched activity inside the cerebellum rise the instant a person moved their own hand toward a ticklish spot, even before contact. The cerebellum was already sending a dampening signal forward to the somatosensory cortex, the brain region responsible for processing touch. Self-generated touch arrived at that region pre-muted. External touch arrived completely raw. This single mechanism explains something far bigger than tickling. It explains why you don't flinch every time your own arm brushes your side while walking. It explains why chewing your own tongue doesn't feel like an alien sensation, even though the same pressure from someone else's finger would feel intrusive immediately. Your nervous system is drowning in self-generated sensation every second of every day. Footsteps, breathing, clothing shifting against skin, your own heartbeat pressing faintly outward. If your brain treated all of that as new information requiring full attention, you would be paralyzed by noise. So evolution built a mute button, aimed squarely at the predictable parts of you. But here's the twist. The mute button isn't really about comfort. It's about survival triage. Every nervous system has limited bandwidth. Attention is a finite resource, and finite resources get rationed according to risk. A self-touch is, almost by definition, not a threat. You already know where your own hands are going. An unexpected touch from outside your body is a different category of event entirely. It could be an insect, a predator, a person with bad intentions creeping closer than expected. Across millions of years, the nervous systems that flagged unpredictable contact as urgent and ignored predictable contact as irrelevant were the ones that survived long enough to pass that wiring forward. This is also why certain areas of your body are far more ticklish than others. Your ribs, your underarms, your neck, the soles of your feet. These are precisely the regions historically most vulnerable to attack. The places easiest for a predator or another person to strike without warning. A 2013 study led by psychologist Christine Harris at the University of California, San Diego found that ticklishness clusters heavily around these defensible zones and that the laughter triggered by tickling resembles a defensive reflex more than genuine joy. People tickled in experiments often reported the sensation as unpleasant, even while visibly laughing. The laughter wasn't happiness. It was closer to an alarm response wrapped in a social signal, a leftover behavior from a time when exposing your most vulnerable areas to another creature required either trust or submission. Which raises an odd question. If tickling is rooted in threat detection, why does it usually happen between people who are close to each other? Parents and children, partners, old friends. Harris's research suggests an answer. Tickling may have evolved, in part, as a kind of trust rehearsal. By allowing someone to touch your most vulnerable areas, unpredictably, and reacting with laughter instead of panic, you are signaling something important to your nervous system and to theirs. You are saying, this person is not a threat, even though my body's ancient alarm system is firing as if they might be. Tickling games between parents and infants may double as early lessons in distinguishing real danger from safe, surprising contact, training the predictive system to recognize a specific person's touch as harmless over repeated exposure. There's a deeper layer still. Some researchers studying schizophrenia have found that people experiencing certain symptoms can sometimes tickle themselves, something almost nobody else can do. Christopher Frith, one of the researchers from the original tickling experiments, has argued that this connects to a breakdown in the brain's forward modeling system itself. If the brain struggles to distinguish self-generated actions from external ones, the predictive cancellation that normally mute as self-touch may fail. The boundary between self and world starts to blur, not just in touch, but in thought. Some patients report hearing their own internal thoughts as if spoken by someone else. The same mechanism that keeps you from tickling yourself may be one piece of a much larger system responsible for keeping your sense of self intact. Think about what that means. The reason you can't tickle yourself isn't a quirky bug in your nervous system. It's a small, visible piece of something enormous. The constant, silent labor your brain performs to separate you from everything outside of you. Every second, it is predicting your next move, canceling the echo of your own existence. So that anything unexpected, anything genuinely foreign, stands out instantly against the quiet. You walk through your life surrounded by a kind of sensory hum that you never notice precisely because your brain has already decided it isn't worth noticing. Your own breath, your own footsteps, your own hand brushing past your own side. All of it muted, filtered, forecast in advance, and in that constant act of self-cancellation, your brain is quietly drawing the line between you and the rest of the world, over and over, thousands of times a day, without ever asking your permission. So tonight, when you reach down and run a finger along your own foot and feel nothing at all, remember what's actually happening underneath that silence. It isn't an absence of sensation, it's the sound of your own brain protecting you, by making sure the only thing left to startle you is the world outside your skin. If this video gave you something you needed, hit like, subscribe, and share it with your friends. See you soon.